So here is a guide video for this problem. And okay, so grass clippings are placed in a bin where they decompose. For 0 to 30, for time between 0 and 30, the amount of grass clippings remaining in the bin is modeled by that function there, where A of t is measured in pounds and t is measured in days. Find the average rate of change of A of t over the interval 0 to 30, indicate units of measure. Okay, so this one, guys, you could do this. This is not a rate. Okay, this is the actual amount of grass clippings. So to do the average rate of change, you just do y minus y over x minus x. So A of 30 minus A of 0 over 30 minus 0. Okay, and do as much of this as you can by yourself. All right, just a minute. I'm trying to use a calculator. Okay, excuse me. All right, so A of 30. Okay, so 6.687 minus, oh, no, sorry, not to the x, to the 30th. Minus, and guys, you could type in 0 if you want, but anything to the 0 is just 1, so this is just going to be 6.687, and then over 30. All right, so I get this, negative 0.9, no. Negative 0.197. Indicate units of measure. This is pounds per, time is in days. Pounds per day. Okay, so that's part A, and you are getting 1 point for that. Where is my highlighter? Okay, so that right there is 1 point. Okay, part B, find the value of A prime of 15. Using correct units, interpret the meaning of the value in the context of the problem. Okay, this is the calculator section, guys, so use Math 8. So I go Math 8. Here I type the variable, which is x. In there I type the function, so 6.687.9 x, and then right there you type the number where that you're evaluating it at. Okay. Negative 0.164. And then this is also pounds per day. Now I need to interpret this in the context of the problem. Okay, so let me start out with the time. Okay, so at t equals 15 days, the amount of grass clippings in the bin, and then you want to say whether it's increasing or decreasing. The amount of grass clippings in the bin is, this is a negative rate, so it's decreasing. Decreasing at a rate of 0.164 pounds per day. Now notice, guys, I didn't say negative because decreasing is telling them the negative. Okay, so for that one you get 2 points. Okay, so 2 points. All right. right, now this next one, part C. Find the time t for which the amount of grass clippings in the bin is equal to the average amount of grass clippings in the bin over the interval 0 to 30. Okay, so here you need the average value formula. Right, so the average value formula is this. It's 1 over 30. Right, that's the length of the interval, 30 minus 0. The integral from 0 to 30. Okay, this is going to give us the amount of grass clippings, the average amount of grass clippings in the bin. And we want to ask ourselves, at what time is this equal to the amount of grass clippings in the bin? So at what time is the amount of grass clippings in the bin at its average value? So this is 6.687, 0.931 to the t. Okay, now guys, for this right here, you could use Math 9, and you're actually going to get a number. Math 9. Oopsie. No. 1 divided by 30. Math 9. 0 to 30. 6.687. 0.931. Okay. And now I'm going to store that. Okay, it's a big number. I'm going to store it. So store, and they're already using A, so I'll store that as B. All right, so this number is 2.752635108, stored as B. Okay, so now I'm going to go to my calculator and I'm going to graph B, which is a constant function. I'm going to graph this, and then I'm going to find their intersection point. Right? Oh, I already used A. All right, so here, guys, I already graphed this, and you want to try to do this on your own, okay? So pause the video and go ahead of me. So here I have typed A of t. Here I want to put B. Window. Oh, actually, let me go to Zoom Standard. Okay, so there's that exponential function. Though that's the amount of grass clippings. It's decreasing. That's the average value. And as you can see, they're intersecting but off of my screen. So I need my rightmost x to be further out. So I go to Window. The rightmost x is the x max. I'll make it 20 or something. Okay, now I need that intersection point. So I go second, trace, intersect, and then I just hit enter 3 times. Okay, and there it is. Okay, so T equals 12.415 days. Okay. All right, guys, now the last one, part D. I like this part. Okay, for t greater than 30, L of t, the linear approximation to A at t equals 30, is a better model for the amount of grass clippings remaining in the bin. Use L of t to predict the time at which there will be 0.5 pound of grass clippings remaining in the bin. Show the work that leads to your answer. Try to do this on your own. All right. So L of t is the linear approximation. So L of t is going to equal A of 30, because we're approximating close to 30, plus A prime of 30, t minus 30. Okay. Now, A of 30 and A prime of 30, those are going to be very long decimals, so I'm going to have to store them. So, all right, let me go here. So A of 30, 6.687 931 to the 30th, okay, is right there. And I'm going to store it. Let me store it now. I already used B. They're already using A, so I'll use C and D. So I'm storing as C. All right, so this is 0.7829278694. Stored as C. Okay, and then A prime of 30. I'm going to do math 8. 6.687.931 okay, I'm going to store that also. So I'm storing this as D. So this is negative 0.0559762123, stored as D. Okay, so they want to know at what time this linear approximation is equal to 0.5 pounds. So I'm looking for this. So I want to solve this equation. So C plus D, t minus 30 equals 0.5, right? So D, t minus 30 is 0.5 minus C. T minus 30 is 0.5 minus C over D. T is 0.5 minus C over D plus 30. Okay. 0.5 minus C over D plus 30. And there it is. Okay, so T equals 35.054 days. Okay, guys, there it is.